In section 9.3, we're going to be adding and subtracting numbers in scientific notation. Now remember, when you're adding and subtracting in scientific notation, the exponents must be the same. All right? So when you're dealing with adding and subtracting scientific notation, not only do they have to be the same, all right, but you then have to add and subtract the decimals and then bring down that power of 10. So if you look at the first example, first thing I want to say to myself is, are the exponents the same? I notice that they are. So I can now look at the decimals. Now this tells me to add, so I'm going to add both 2.56 and 6.94, and I'll get 9.524. Once I have that figured out, I take the exponent, which is 10 to the third and 10 to the third, and just drop it down to my final answer. So I'll get 9.524 times 10 to the third power. Let's look at another example. Example number 2 tells me to subtract, but I quickly notice that they are both raised to the fifth power. So far I'm in good shape. I want to look at my decimals. I want to subtract them. 9.49 minus 4.863. I get 4.627. Now, because both of my exponents are the same, I'm going to drop those down, and I get times 10 to the fifth power. That's my final answer. Now, when you're adding and subtracting with different exponents, okay, you must move the decimal so that they will have the same exponent. Again, we're going to have similar steps. You're going to rewrite first, which is going to be the new one. Then you add and subtract the decimal, and then you bring down the given exponent. All right, first example tells us that, or actually shows us that 10 to the 6th and 10 to the 3rd are completely different. So it's your choice. You can make them either both 10 to the 6th or 10 to the 3rd. Now I'm going to take this 10 to the 3rd and make it 10 to the 6th. I think it's easier. In doing so, I'm taking 10 to the 3rd and making it 10 to the 6th. So I'm adding 3 decimal places, not just 3 values, 3 decimal places. So if I move this over 3 decimal places to give me 10 to the 6th power, I have to move this 3 decimal places in the opposite direction. So this becomes 0.0034. Now all I'm doing is I'm rewriting this, and I'm rewriting it to this value. So I have 0.0034 times 10 to the 6th. Now I have a completely new problem. I notice that these are both raised to the 6th power. So I can add my decimals and then bring down my 10 to the 6th power because they are the same exponent. All right, now in this particular case, they rounded, but you don't have to do that. Okay, let's look at example number 4. One of the exponents is 10 to the 3rd, and the other is 10 to the negative 1. I'm going to change them both to make sure, actually I'm going to make sure that they're both 10 to the 3rd. So I'm going to change this 10 to the negative 1. If I make it 10 to the 3rd, I'm adding 4 decimal places. So I'm making this bigger by 4 decimal places. I need to make this smaller by 4 decimal places, which is 0.000265. So really what I'm doing is I'm making this a completely new value. Same value, but I'm just changing the way that it looks. So now that these both have the same exponent, I could subtract my decimals. 5.762 minus 0.000265. I should get 5.762. This is rounded as well. You don't have to round it. All right, so once you get that answer, you put it down here. And because the exponents are both the same, I have 10 to the 3rd, 10 to the 3rd. I just drop it down. And I just write it once. Oops. 5.762 times 10 to the 3rd. And that's pretty much it, guys.